So we're actually going to be talking about exponential functions. And exponential functions always follow the form of y equals c times b to the x power, where c is the the y-intercept, and b is the base of the function, which tells you whether it's increasing or decreasing. So if I make my c 2, you can see that right now the y-intercept is 2, and b determines whether it's increasing or decreasing. So right now, if I set it to 2, then that means that it's growing at twice the speed. That means that it's doubling each time. So 2 doubled is, so if you double 2, that's 4. So that means that it's up here at 4, at the point 4. And then 4 doubles is 8. Then 8 doubled is 16, 32, so on and so forth. So that's what that means. And so if we make it 3, then that means that it's growing at triple the speed, and that means that it's going to be growing faster. And same thing if you go to 5, and then 7 and 10. So it just means that it's growing faster and faster if it's greater than 1. But if we take a look at something that's less than 1 as a fraction, let's say 0.5, anything that's a fraction actually makes your graph look like a decreasing function. So this one is it's decreasing exponentially. And anything that is less than -1, anything that's less than 0 actually, any negative number makes the graph go away. It disappears. That means that your function, an exponential function, cannot have a negative base. That means that your base has to always be positive. And if your c is negative, then that just means that your y-intercept is going to be in the negative sides. So c can be negative. You can swap c from c can have a y-intercept of positive 2, and you can also have a y-intercept of -4 if you choose. So so c can be negative. So depending on what c is, it's either pointing up or down. And so as we said before, so the graph where you have 2 to the x, that means that it's growing at twice the speed. 3 to the x power is in triple the speed, and 10 to the x, that's growing at an even faster speed. And then a half, it's decreasing half the speed. And then 1/10 is smaller than a half, so that means that it's decreasing at a faster rate. And from this example here, we can see that it's still doubling, but this time the y-intercept is at 3. And similarly here in this case, 0.2 is actually a fraction. So because it's a fraction, it is still decreasing, but it is being reflected over the x-axis because we have a y-intercept of -3. So our y-intercept in this case is -3, which is why it's pointing down. We're also going to be talking about e. E is similar to pi in the form that it has it's actually an irrational number that is approximately equal to 2.71, so on and so forth. Similar to pi, which is 3.14, so on and so forth. So in this case, our base is 2.71, blah, blah, blah. And so that graph, since it's bigger than 1, it's increasing, and it has a base of 2.7. And since the number in front of e is 1, that means that our c is 1 as well. So our y-intercept is 0,1. And we're also going to be talking about the natural log. I'll introduce that in the next video, but the natural log is basically the inverse of e. So if you guys take a look at, from what we talked about inverses, a function is an inverse if you see it reflected over the line y equals x. So this is actually symmetric to each other. The graph of ln is symmetric to the graph of e to the x once through the graph of y equals x. So that means that they are inverses of each other. And we're going to talk about logs. So logs is the log is the same thing as ln with a base of e. And if you guys notice, all of the log functions have to be greater than 0. There is no x values to the left of the x-axis because the x values for a logarithmic function have to all be positive.